Hello everyone, May 22nd, Saturday. I just had a good meal, some Impossible Burger with Chinese fried stick. That was wonderful. Oh, and some nice juice. Alright. One more thing, and also a brownie cookie mix. Alright, it's a brownie and cookie mix together. Wow, this is some great, great morning food. So, I'm well fed. Let's do this. It's a Saturday, which means going to be difficult. Queens. We did this long time ago. My God. Oh wow. I think I did this when I first started, and this is like number like within the first 20 questions if I remember correctly. But Queens is tough. Yeah, it's a difficult one, and I used to know how to solve it fast, but I do not anymore. Look at the constraints, right? So you know this is a hard question. The constraint is the 1 to 9. All right. Let's just do this again. Place n queens on an n plus n chessboard such that no two queens attack each other. Given integer n, return all distinct solutions to the n queen puzzle. Each solution contains a distinct board configuration of the n queen's placement where q and dot both indicate a queen and an empty space. I think a queen can attack vertical, horizontal, and diagonal. Yeah, I think that's yeah. All right. All right. I might or might not be able to solve this, even if I did this before, but it was a long time ago. N queen is, I think it's a very classic problem. I should know how to do this, right? All right. So I think it's backtracking. So we basically say we place the queen in the first spot, and then we eliminate the plot that cannot be, right? And then we place the second queen in the second row, some spot, and then we eliminate the ones that cannot be, right? Eliminates the one that cannot be. Then we place the queen in the third spot and eliminate, and then we find the last was nothing, so this one's wrong. So we go back, and there's no other choice. We go back, and we do have another choice. Now we try it. And then is there any dynamic programming in it? I'm not sure. I'm just trying to figure out right now. So I put in here, go down, right? And then I put here the only choice and nothing. So this one's no good. So we go back to the first and we put in the second one. Yep. And I think what I was solving, I was also thinking about, this thing has a little bit property of symmetry, right? It has a symmetry property. So I was thinking you only need to go half. That's what I think. You only need to go half. I'm not sure. Honestly, I'm not sure. I think it's only need to go half because but this is a mirror image, right? Oh man. How do you eliminate? Well, we can. Every time we set it, we eliminate, and then we find the ones that's available. Right? Eliminate, find the one that's available, eliminate. And we do it like a recursion. Current row, yeah. How do we it's not that big. It's 9 by 9, so every time we can copy it. Can copy the chessboard. do the elimination, and then okay, so we can put the chessboard as we need like a different symbol for position that is open. We can say position is open, it's going to be O, right? Position that cannot take anything else, that will be a dot. Yeah, I think we can solve it like the stupidest, like just brute force, right? Brute force. I remember there's a like maybe a smarter way, like not really brute force way. I don't remember. I don't know how, but I think brute force shall work because it's so small, right? The chessboard is so small, so I think it should be fine. Brute force, even though it's sounds pretty bad, but I think brute force shall work. All right, I think the first time I do this, I don't remember if I complete it or not. Maybe I have, maybe I haven't. Solve this. I think I need a call a helper, right? I need to call a helper. So helper, I don't need. Oh, I didn't even give you the board. You have to handle the board yourself. Okay. So the board, do we pass the board? We have to pass the board. So we have to pass the board. Right? The pass board can be list of str. So that's the board. So we pass the board because each time we pass down, it's gonna be a different board. Because I don't want to do like the backtrack. So you set and then you reset. So we can just copy and paste. So we have the board, and we're in the current row. We have the current row, and we don't have to return anything. Return a none. And we're gonna set a rest. Gonna be this. Yeah. Okay. So we have a board, right? And then for the row, then we're gonna say every time we call it, we just go through, and we just want to find if there are any openings, right? I'm gonna say for p, calling position in board row, right? If p is equal to O, because this is what I want to assign, I want to assign O as open, right? It's open. So if p is O, then we put a queen there. If p is O, then we are going to copy. So we're going to say board copy equals board. So I'm going to copy the board, and then I'm going to say board copy p, not p, That's going to do IP in enumerate. So it's going to be I, no, row I, and equal to Q, right? And then everything that it holds, so vertical. So it's going to be for J in range, N doesn't change, right? I'm going to say board copy row J equals a dot. Actually, we're going to do this one at the end because everybody else needs to become a dot. And for K in range N, right? And then we say board K, right? That's the K. We want to do the column, right? The column. So K, column what? Which column? I. Column's I. Now I don't like column I. I like column to be J. So let's do this one J. And this is row, going to be I. Right? So row I. Oh no, that is also J. That is a column. This is a column. We have 2 columns. Ay, ay, ay. All right, fine. This is I. So this is the main column. So this is just to sweep through. Right, let's sweep through it. Use the same. Use the same. Then this is going to be J I, right? J I. That equals this. Now diagonal. Diagonal. Diagonal from any point going up and from any point going down, and then going the other way. Oh, yeah, I do remember one way is to use bitmap. I think there's one way that people use bitmap. I don't remember. So, but anyway, so we're gonna say I cannot use P anymore, so I can use MN. Let's do MN. I say M N equals 0, 0. I'm gonna say while. No, we're gonna start with M is the row, no row. N is I don't like it. I don't like it. It just confused me. Column, right? And then this is going to be row, column. This is going to be column, and this is going to be I because we're going through the rows. Yeah, it would be I. And then it's going to be row and column, right? And then we say while M is row, so M is going to be smaller and equal to 0, right? And we say diagonal board MN equals this, right? And then M minus equal 1, N minus equal 1 as well. So this and N is larger equal to 1. Why do you say smaller equal to? Both are larger equal to 0. So that's, we just handle 1. And we have to go the other way down. Oh my god. So we just do, this is 1. And then this is going to be, this is go northeast, all right? So let's say this one go northwest. So N is smaller than I. Cannot use N. We already use N. I did A and B then. I don't think we use A and B. Alright, so this is going to be A. And this is going to be I. Can have it. It can be B. Alright, so it's going to be B. It's going to be B. 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 B is for column. So B gonna be plus equal to 1. Actually, if you look at this, maybe we can do it in one shot. Yeah. No, we cannot, because some might end earlier than the others. And just, it's easier to do this way. So northeast, I'm going to south. Southeast. So southeast will be, B is going to be largely equal to 0. Hold on. That's larger than 0. Larger than 0. Oh yeah, that's not east. That's west. That's northwest. This is northeast. This is going to be northwest. So A is going to be smaller than N, and B is larger than 0. So go south, west. Exactly. So A is going to be plus, B is going to be minus. And the last one will be southeast, and both I think is smaller or smaller than n, and both gonna be plus, right? So we turn everything, and then eventually we put this as a Q, and then we're gonna call helper board CP, and row plus 1. Go to the next row, right? And we keep going, keep going, keep going. Like if nothing is O, right? If nothing is O, actually like lowercase o. If nothing is open, then that just ends. And we don't have to worry about it because and also we don't have to roll back because we did a copy here, and we need to check if so. So the last one we did it, and then we call row plus 1. So if row equals n, right? If we get to row equals n, then rest dot append board, because board is copy, so we can append it directly, right? And return. That's the end. Otherwise, we do this, and we're gonna call it. We say helper. Oh, that's gonna be O times n, right? And for this in range n, that's the board, initial board, and then row 0, and we return rest. Okay. Let's see. I think we can get it right. As long as we can get it right, it should be fine. Because I don't think there is such a thing as timeout. This is I don't think it's possible to timeout. Simply because we only have like the largest n is 9, so I think it should be fine, even if it's not the optimal. Well, let's see. Let's see what we have. C. There we go. Okay, and this is going to be n. Answer is going to be solve queens. Try it. S is not defined because there's no S. Result is empty. Why my result is empty? That is very weird. The second one, ooh. Hold up. Oh. Oh. Oh, shoot. Shoot. This is going to be append. We have to turn this into, okay, so for row in, hold on. Yeah, for row in board, we need to make it into row dot join. No, not row dot join. It's this dot join row for row and board. Okay. All right. So I want to figure out this first one. If it fails, right, and then we go to the second one. Yeah, why would it fail? Nothing is put into the rest. But every time it's a copy. Like we didn't touch anything on the board. We copy the board and make all the changes, right? And the next one we'll copy the board and we'll make all the changes. And then row plus 1. I guess just every time we call it, let's just print out. Let's just see. For row in board, let's just print row. Let's kind of see what happens. And this we don't need. The hell? Where? List indices must be integers. Board row. Not list. Huh? What do you mean? This is a board? For column P in numerate board, list indices must be integers or slash, not list. I never pass it as a list. Oh, because of this. Now so that's gonna be not row. My bad, this gonna be R. Oh, I didn't say. We need to also to print current row and also print some other stuff to show that this is an individual. Okay, so this is the one we enter, and the next one. So we enter, and we say if P is 0, right? And then we say, oh, here, this is not I. There's no more I. This is going to be column. There we go. So Q is here. It's still wrong. So yeah. Second one, Q is here. Oh, really? We already killed everything. And the third one is no good. And I think we just stop. How? Hold on. This is not right. Right, so we go, this is the second row. 0, 1, 2, right? So 2 is go, is nothing, right? Is nothing, so we shall return to the previous one, right? So return to here. And yeah, we take this, and then we shall return to the previous one. Wait, what? That's not right. How? Oh, I think I know. I think I have to call copy a deep copy. So I think I need to import deep copy or import copy. And we need to say copy.deep copy. There we go. Now we pass. Yeah, because we copy on the first layer, but we use a list of lists, so we have to copy on both layers. And this is pass, and I think this one also pass. Okay, let's take a look. Let's hope it doesn't time out. I think I Control C it again. All right, let's see. Okay, timeout. Yes, no timeout. Good. All right, so I think what I say is straightforward backtracking. Since the size of the board is quite small, we can make a deep copy. Yeah, we can make a deep copy instead of actually backtracking. Deep copy of the board for the next round instead of actually backtracking, right? Runtime. No idea. Runtime. Runtime. How do you handle runtime in this situation? I mean, the worst case will be, well, that's actually no worst case. Just like it's deterministic, right? So we're gonna hit every single one once, and then that's O n squared. But then it could be wrong, so we track him back and do another time. Actually, I don't know. Actually, I don't know. I hope I can see analysis on the runtime on this. And again, I remember there are ways, instead of like traversing, they use a bitmap. I don't remember how to do that. And we are at the low end. Yeah. Oh, what? I don't know. And 488 milliseconds. 7.7% ranking. All right. Did I solve it last time by myself? I don't remember. This is a classic. Try to get educated again. What's the last time I did this? Last time was 2019. Oh, I did do it in the first time. That was my Java and C++ days. How does it look like? Mark impossible. Mark impossible. Yeah, so everything is similar. I'll have a time limit. So I did it, yeah, I think in February the first time. And then I did it again. I used some 20 milliseconds. Why is it different so much? 9 test cases. I use a different method to become 20 milliseconds. Still gigantic. So that's that. And then it lasts for 2 days. The next one I started doing it was May the 30th. That's the second time I started doing it. Why did I do it? I have no idea. Maybe just got interested in it. And now today. Wow, that's actually 2 years. May the 30th. That's the second time I did this problem. So now it's May 22nd. So I really liked it. Backtracking. I mean, that's the way we do. Oh, holy moly. Wanna read that? That's it? That's it? Why is my runtime so much worse than other people then? What do you guys do? What is this? I can see like one reason, right? Why it doesn't be bad is because of this, the copy. We're doing a copy. Maybe we can try it without copy, and it will be. What is this? Backtrack. Yeah, this is fine. This is just to return the result. And control RT LT blah 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 blah. Where is the backtracking part? What do you call? Wait, this is, where's the backtracking call? Here is the call. Ah, yeah, you see that? You see that? It's the same implementation, but they don't do is they have a smarter way to handle the checks. Okay, I want to first read the time complexity, and we know how this is done, right? It's just backtracking. I think it's just the diagonal. Like how do I handle diagonals? Diagonals are removed, columns. Let's see, get some intuition. General board states. Now, when all possible and exhaustive backtracking by removing the queen and place it elsewhere. What we can do is we say we put a queen down, then we have a spot that we can now go. So we know, like we put it down. At least like we don't have to do this because we're gonna do row plus one no matter what. So this we don't need to do. We're gonna do row plus one. This we do need to do, but we can be smarter with the column because I can just pass down which column has been taken already, right? All right, think about it this way. Think about it this way. When I put a queen down, right? When I put a queen down, what happens is we know which row and which column is bad, right? Is bad. We know it's bad. And then we just need to know, because we're going down. We're always going down. So diagonal-wise, we don't even have to do the northeast and northwest. We're going down. So all we need to do is the south. The south. So we can actually simplify this directly. We can give it a shot. You can simplify this directly. Like we don't even change the representation or anything. We just say we are not doing the rows, right? Rows is not necessary, and these two are not necessary. All we need to do is the south. And let's try it. And it still passed, right? So I think this one will be noticeably faster. Because if you think about it, the north, who cares about the north? Right? It doesn't really matter about the north. What matters is south, because we're going down. And of course, we also don't care about going, we don't care about going southwest and southeast. And in that sense, yeah, I think we shorten it tremendously. No need to mark the board on the north side because we are going south each step. So same runtime, but I think this one will be faster. If you're not sure, I'm gonna run another test case. Let's say an 8. Yeah, I think it's good. So I run this. We'll get, I mean that doesn't remain. That doesn't mean anything. That does not mean anything. So it's the same, right? Basically, it's the same. But we did save time. Right? We did save time. So the next thing is, can we do it without using the copy? I think if we, without using copy, it'll be faster. Much, much faster. So if we don't do the copy, what we need to do is, so what we do is we go, this is the column. Oh, we also don't have to go with n. We can start from the one below us, which is row plus 1, right? So it's a row plus 1 to n. We do this. And this is going left and right. So we can just say, like, instead of no copy, yeah, no copy. So let's just do this, right? And after we do it, we're gonna run the whole thing again. Run the whole thing again to backtrack. So we're gonna call it backtracking, right? So basically it's the same thing because we set it to this, we're gonna set it back to open. And same thing, we set it back to open, and we set it back to open. Then we go on the next one. Do I set back this one as well? Row column, yes, because we did not set. I mean, we can just do this, then we set it. Okay, and try it again. Ay. This is not correct. What happened? The backtrack, if this is O, then we don't care, and then now we do have to do the row as well, because when we copy we don't have to do it, but now we're not copying. So if we're not copying, we set everybody else, but we didn't set my current row, right? So we have to set the current row as well. So we have to set the current row for I in range n. We say board row I equals this, right? We set it that, we set it that, and then we probably need to set the other two as well, I guess. Yeah, probably need to set the other two as well. And of course, we have to set it back. Forgot to set it back. So, oh, we cannot set it back to exact. Yes, actually, we can. Hold on. So on the row, I see if there's an O, right? And then I see it. I set everything to this. Actually, no, I don't think this one works. I don't think so. I don't think so. Because we have to maintain the state. Right? We have to maintain the state. Like where the openings are. So I can move on to the next one. If we set everything to a dot, then we don't have the state anymore. So I don't think that's the way to go. Nope. Let's go back. Take a look again. We don't have to read. Let's just. Oh yes, row minus column. I think that is. Oh yeah, the diagonals. It's row minus column. The row minus column is always going to be the same value if we want to go diagonal. Yeah. Then what? The row minus column. Anti-diagonal is row plus column. Will be constant. Yeah. Calculate the diagonal and anti-diagonal values belongs to set to keep track of which columns have been used and which. So we keep track of which column. Yes, that's true. we keep track of which columns. Column, that's just one value, right? So row, we don't have to worry about row. So we just keep track of column and keep track of, yes, the row plus column, that's the anti-diagonal, and row minus column, that's the diagonal. Or columns minus row, it's the same thing. So these three will determine on the next one whether it can or cannot be, and then we just adding the position of the queen position. I think I'm almost there. So once I have a position, say at 0, 1, then diagonal wise, if the sum is going to be 1, then that's a no good. And anti-diagonal, hold on, anti-diagonal, this is plus, right? This is diagonal. It's the minus. Yes, the minus. So we have the minus, plus, minus. So every row I just go through, and we have a set of columns, and a set of columns diagonals that we cannot that has already taken. I'll just see if it fits. If it doesn't fit, if it's not in there, then we can take it, and then we add new things into it. If it can, and we remove it, that is the way to go. So again, we don't have to, the board is just, we don't even need to use a board. Just think about it, we don't need to use a board. There's no such a thing as a board. And we just, I think we only need to use a row, right? That's only we need. And when row equals n, then we actually need to queen's position. So queens, right? So queens is going to be a list of int. And just each column, right? Each column on each row. And then we're just going to append. So we're going to say let's say for Q in queens, right? What do we do now? That'll be interesting. How do we turn that? So we know the position, and what we're going to say is, I think we can do it this way. So I'm going to say temp equals this times n, right? And for Q in queens, now actually it's be here. For Q in queens, nope. Q in queens, temp is this, R is this, and RQ equals Q, right? And then temp is going to be empty, because I want to append that. Let me say temp dot append dot join dot join R, right? And then once we're done, rest dot append temp, right? So that is when we find it. Otherwise, every time will be for I in range n, right? Or in range n, and when I put on the outside, we call it the columns. Columns is going to be a set, right? And then left to right, diagonal. Diag, left to right is going to be a set. Diag, right to left. Actually, I don't like this. We're going to go upper... Man, how do you describe this diagonal? This diagonal is... upper left, lower right. Right? It's going to be upper right, lower left. It's just looks so ugly the way it's expressed. Alright, so diagonal. Let's say this is a diag. And this is going to be anti-diag. I'm just following here. Anti-diag. It's also going to be a set. So this is going to be diagonal, upper left to lower right. And this is going to be upper right to lower left, right? So I have two diagonals, so I have columns. So this is when we're good, and this is when we're gonna go through each single one of them. And I'm gonna say if I is gonna be a row, I have a column, so we have to call it J. So if J not in columns and we're gonna do row minus column, not in diags, and row plus J, not in anti-diags. No diag, it's just a diag. Right? So if it's that means it's a good one. So we can say queens dot append J. Then we call helper again. We call helper row plus 1 and queens. And blah blah blah, we're done. Now we're gonna roll back. Oh, hold on. How could you roll back? You haven't even finished the columns yet. So columns dot add J, diag dot add row minus J, and anti-diag dot add row plus J. And then we go helper, and then we go backtracking, which is first of all queens dot pop, and then columns dot remove J, diag dot remove row minus J, and anti-diag dot remove row plus J. Right? Once you remove those, then you keep going for the next J. And once we're good, we're coming out. And I think that's about it. So I'm gonna call it helper. Row can be 0. Queens is just an empty list. And then we return rest. Try it. Now we pass. This is the solution from the official solution. The use of row minus column and row plus column to represent all diagonals that a queen can reach is the key trick in simplifying this problem. Because we can use numerical values to represent the impossible positions. We don't even have to set up a chessboard in the first place. So very, very smart. And then they say it's ON factorial. I'm gonna take a look, but I want to try to run it first. Run code. Yeah. Submit. This one should be fast. Oh, look, the speed. 56 milliseconds. 84. Yeah, so I think this is maybe the second or third time that I encountered the use of row minus column and a row plus column to represent the diagonal values. Why can I never memorize that? I don't know. All right, time complexity. N as the number of queens, same as the number of width and height. Unlike the brute force, we'll only place queens on squares that aren't under attack. Wait, they have a brute force? Approach. Oh, that's the brute. No, we're not gonna do brute force. Oh, I know. So yeah, for the first one, we have n possibilities. For the second one, we can say we have n minus 1 It's actually not n minus 1, n minus something possibilities. And every time we simplify it, it's just going to be n, like next queen. So, and there must be at least one square attack diagonally by the first queen as well. Thus, the maximum number of queens, so we can consider n minus 2. That's true. Well, it could be 3, right? Yeah, it could be 1, it could be 2 or 3. 2 or 3. It could be 2 or 3. But the maximum number is n minus 2. That's true. For the third queen, we only plan to place it in 2 columns. Already occupied, yes. There must at least 2 squares attack diagonally. Yes, I can see how that happens. Thus, the maximum is n minus 4. Approximately in factorial. Yeah, the amount to build is nothing. 3 sets use the storyboard state. Okay, so yeah, it is factorial. And oh boy, how is this one? Wait, do you have a better way to build? Now, a row. They have a board, I think. They have a state. Ah, they do put it inside a state, and then we return the state. Ah, they do have a state, empty board. They do use a board, and I didn't use a board. I just created it at each time, and that's fine. That's just micro optimization. It doesn't really matter too much. Wow. Yeah. So diagonal. Yeah, it's something to always remember. I think when I was doing this solution, I didn't even think too much. I just say, okay, I just follow the trajectory, how the problem is supposed to be solved, right? Straightforward, no tricks. But with tricks, it can be significantly faster. $51. Yep, I know it's an early question. And a long time ago. So this one is 51. And it has lots of discussion already. All right, that's it. That's good. We kind of, revisit the old problem, and I didn't get it. It's a terrible solution anyway. So I didn't get it, but reading back, just again, right, one more time, trying to memorize, kind of just get this into my head, right? This is the trick. Try to get this trick into my head. I mean, it just didn't occur to me. Yeah, plus and minus represent the column and row. The sum and difference can represent the same diagonal. That's basically the thing. All right, that's it. That's it for today. Tomorrow most likely is another difficult one, so we're gonna go for it. See you guys tomorrow. Adios.